Hi everyone. In this video, we are going to talk about how to approximate the area under a curve. So here is the problem. We have a graph of some function y equals fx, and we have 2 points, x equals a and x equals b. So between this curve y equals x, y equals fx, and this x axis, and these two vertical line x equals a and x equals b, we have a bounded region, right? And now I will show you what can we do if I wanna approximate. Remember, I'm not talking about how to find the actual area. I'm just show you how to find the approximation, how to estimate the area of this region. Later on, we will talk about which method shall we use if we want to find the exact result, if we want to find the exact area. But at this point, we only talk about the method to find the approximation. Okay, so the idea is I'm gonna divide this this bounded region by using some rectangles. Like here, I use 11 rectangles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, when we choose the rectangle, we want each rectangle to have the same base. So the width, in other words, the width of each rectangle is the same. Okay. Now, and we can determine that. We can determine the length of the base using this formula, b minus a over 11. Why? Because the distance from, or the length from the point A to the point B is given by b minus a, right? And if I divide this into 11 pieces, so the length of each piece is given by this number, b minus a over 11. Now, if I divide this region by using 10 rectangles, then the length of the base will be b minus a over 10. If I use 5 rectangles, then the length of the base will be b minus a over 5. So this means the length of the base of each rectangle depends on the number of rectangles we are using. So we can use this formula to find the length of the base. Okay. So now I use this notation, delta x, to represent the base. So the delta x equals this number, b minus a over 11. Okay. Now you can see the height of each rectangle is not the same, right? Now, how do we determine the height of each rectangle? We use the function value. We use the function value to determine the height of each rectangle. Say, for the first rectangle, I use the function value at this point A to determine its height. So what does this mean is suppose so here is the graph, right? And this is A, and by the way, if the base of each rectangle is equal to delta, is equal to this number, So that means the difference between A and this point is delta x is equal to delta x, right? So since their difference is delta x, this point, the coordinate, we can represent by using A plus delta x. Now the next point, the difference is delta again. So the next point will be this number add by delta. So it is a plus 2 delta x. Okay. So here I want to draw a rectangle. So since I said I'm gonna use the function value at this point to be my height. So when I draw the first rectangle, because the function value equals this, f of a equals this, so the first rectangle gonna be like this, right? So that's why we have a little bit, we have this a little bit area, this little bit piece over this curve. Okay, and for the next for the second rectangle, I use the next point, the second point. I use the function value at the second point to be the height. So that's why when I draw the second rectangle, it is like this. Okay. Okay. So by following this way, for the last rectangle, for the 11th rectangle, its height is determined by the function value at the point x equals a plus 10 delta x, which is this point, right? So this point is a plus 1 delta x, 2 delta x, 3 delta x, 4 delta, 5 delta, 6 delta, 7 delta, 8 delta, 9 delta, 10 delta. So this point is the a plus 10 delta x. So I draw the rectangle here. Use the height is given by the function value at this point. So that's why it is like this. Okay. Now you may already realize that there is one point we didn't use, right? Which is the last point B, because we only have 11 rectangles and there are 12 points. We didn't use the point B because so we only need 11 points. So that's why we don't use the last point. And if the height of the rectangle is determined by using this method, by using the left point, by using the left endpoint of each interval. So here we have 11 intervals, right? For each interval, we use the left endpoint to determine the height. And this method is called the left endpoints method. Like here, consider this interval. And when we construct the rectangle, I use the left endpoint to determine the height. So the rectangle I draw is like this, right? Now, if we have a left endpoint method, we also have the right endpoints method. So if we use the right endpoint method to construct this rectangle, you can say it will be like this. So because this time I'm using the function value at this point as the height, so that's why the rectangle I graph gonna be like this. Okay. So let's go back to this picture and see what if we use the right endpoint method to draw the rectangles. Then what do those rectangles look like? So here I already had 5 rectangles done. Okay, let's continue on the rest. So the first rectangle, I use this point, the second point, to determine the height. And for the second rectangle, I use the third point to determine the height. The third rectangle, I use fourth point, and the fifth point, and the sixth point. So now for this rectangle, I'm going to use this point to determine the height. So so the function value at this point is equal to this. So the rectangle gonna be like this. Okay. Okay. Now for the next one, the function value of this point is here. So the rectangle gonna be like this. Okay, and now let's move on to here. This point, the function value is here. Okay, and for this point, the function value is this. Okay, and for this point, the function value, okay, it's almost the same. Okay. And for point B, the function value is this. Okay. So let me corner these rectangles. So when I use the right endpoints method, I'm gonna use the I won't use the first point A. So the first point I use is the point A plus delta x, and the last point I use is B, or is A plus 11 delta x. Okay. So this is the difference between the left endpoint method and the right endpoints method. Okay. Okay. Now let us use this method to try this problem. We use this information given in the picture to approximate the area under this curve y equals 2 minus x squared from x equals 0 to x equals 1 using 4 rectangles and using a right endpoints method. Okay, so the key information is this. So this tells us the function is 2 minus x squared, because we're gonna need this function to figure out what is the height of each rectangle, and it's from 0 to 1. So this tells us a equals 0 and b equals 1, and we're using 4 rectangles. So n equals 4. So these three numbers gonna give us what is the base of each rectangle. So the base is the difference between these two numbers and divided by 4. So it's 0.25. And we're using the right endpoint method. Okay, so let's first think about when I divide this this interval from 0 to 1 into 4 pieces, into 4 even pieces. Now, what are the coordinates of each point? Now, to figure out what are the coordinates of each point, we need to know what the base is. Okay, so now the base is 0.25. So the base is so the delta x equals 0.25, right? So the difference between this point and 0 is 0.25. Therefore, this point is 0.25, right? And the difference between the third point and the second point again is 0.25. So we add 0.25 by 0.25. So this is 0.5. And the next point we add 0.5 by 0.25. So that's 0.75. Okay. So I have these 5 points, 0, 0.25, 0.5, 0.75, and 1. And since we use a right endpoints method, then when I construct the rectangle, I'm gonna use the function value at the right endpoint to be the height. So for the first rectangle, it should be so that's the function value at 0.25, which is here, right? So the first rectangle gonna be like this. Okay, and for the second rectangle, the height is a function value at 0.5, which is here. Okay, so this is height, right? And then we connect this point with this point. We draw a perpendicular line, so we can have a second rectangle, and the third rectangle gonna be like this, and the last rectangle gonna be like this. Okay. Okay, so then the next thing we are gonna do is to calculate the area of each rectangle, and then we add them up. That will give us the approximation to the area under this curve. Okay, so for the first rectangle, okay, first we can go ahead to write the width of each rectangle because they are the same numbers. it's 0.25. Now the height of the first rectangle is the function value at 0.25, and the height of the second rectangle is the function value at 0.5, and for the third rectangle it's function value at 0.75. For the last rectangle, the height is function value at 1. Okay. So that is at this point we're gonna need to use this function fx. So this is a 2 minus 0.25 square. This equals 2 minus 0.5 square. This equals 2 minus 0.75 square. This equals 2 minus 1 square. Okay. So f of 0.25, f of 0.5, f of 0.75, and f of 1. Okay, so it's 1.9375. Okay. 1.9375, and that's 1.75, 1.4375. And that's 1. Okay. Once we know the base and the height of each rectangle, then we can find the area of each rectangle by multiplying the width and the height. So for the first rectangle, the area is 0.25 times 1.9375. So we multiply this by 0.25. So that gives us the area of the first rectangle, which is 0.4848. Sorry, 4844. If we keep only 4 decimal places. So this is 0.25, 0.4375. And for this one, it's a 0.3594. For the last one, it's 0.25. So the sum of them plus 0.4375 and plus 0.3594 and plus 0.25 is a 1.5313. So the approximation of the area under this curve and between 0 and 1, this is about 1.5313. Okay, now I would like you to try to do this problem again using the left endpoint method to see what is the result, what is the answer you get.